Hello, this is Mohammad Furqan from Group 3 and I will be analyzing operational amplifier and I will cover some of its applications in this video. So what is an operational amplifier? It is an integrated circuit that amplifies the voltage difference between the two voltages that are connected to the inverting pin and the non-inverting pin of the operational amplifier. Operational amplifier is used for many purposes like making a voltage buffer amplifier, differentiator, integrator, precision rectifier, peak detector and filters, etc. I will be covering some of these applications in the later part of this video. In the right part of this slide, I have shown the symbol for operational amplifier. Now moving on to one of the most used operational amplifier circuits, which is operational amplifier 741 IC. As we can see in this figure, it has 8 pins, out of which 2 are input pins, 2 are power pins, 1 is output pin, 2 are offset null, and offset null is basically used to make inverting and non-inverting pins equipotential when there is no voltage connected to the inverting and non-inverting pin of the operational amplifier. And there is one more pin which is not connected, pin 8. Now before moving on to applications of operational amplifier, I would like to introduce uh, how the inverting pin and the non-inverting pin works in an operational amplifier. So for that, I will connect the input voltage to inverting pin and I will ground the non-inverting pin. And as we can see in this figure, we have this node X, and after applying KCL and Ohm's law at this node X, we get V out equals to minus RF by R in times of V in, which means that V out is inverted first of all, and it is amplified by a factor of RF by R in. And we can also change this gain. Gain is basically RF minus RF by R in. We can change this by varying RF. Now let's see how non-inverting pin works. So for that, we will connect the input voltage to the non-inverting pin and we will make a potential divider, and the partition between R1 and R2 is connected to the inverting pin of the operational amplifier. And let's assume that this node X has the same potential, almost same potential as V in, and after that we will apply KCL and Ohm's law at this node X, after by which we can get V out equals to V in times of R2 by R1 plus 1, and from here we get the gain equals to R2 by R1 plus 1, which is obviously greater than or equal to 1, which shows that first of all it is amplified and V in and V out are in same phase. And from this, one thing also we can observe is that we can easily make unity gain amplifier from this circuit just by taking R2 very small or making R1 very high. Unity gain amplifier is basically an amplifier where the V out and V in are almost same. So our first application is differential amplifier. Differential amplifier basically amplifies the difference between input signals and it suppresses the common voltage between them. So for making differential amplifier, let's consider the circuit that I have shown in this figure. In this circuit, let's assume that the two nodes between R1 and RF and R2 and RG add some potential X, and by using KCL and Ohm's law at these two nodes, we get X minus V plus X minus V out by RF equals to 0 and X by RG plus X minus V2 by R2 equals to 0. And after solving this, we can express V out as AD times of V1 minus V2 plus AC times of V1 plus V2 by 2. Here AD is known as differential gain because it tells us the amplification factor by which the difference between two voltages are amplified. And AC is known as common mode gain because it tells us the factor by which the common voltage V1 plus V2 by 2 is amplified. For making better differential amplifier, we want to basically we want to increase AD so that the difference between the voltages is amplified, and we don't want common voltages, so we want AC to be low. So for measuring the ideality of this differential amplifier, we are introducing a term known as CMRR, common mode rejection ratio. It is basically the ability of differential amplifier to accurately cancel common voltages, and it is defined as 20 log AD by AC. And obviously AD by AC will the term will come out because we want AC to be low and AD to be high. Now moving on to the next application, precision rectifier. Precision rectifier is basically a rectifier which is made using op amp and diode. As we can see in this figure, whenever V in is less than 0, then the diode will be in reverse bias, thus the V out will become equal to ground voltage which is equal to 0, and whenever Vin is greater than 0, then the diode will be forward bias and Vin will approximately equal to V out. So this device works as a rectifier. Now moving on to our third device, peak detector. Peak detector is a device which will uh, detect peaks in the input signal. So for this, we will basically modify the precision rectifier by changing the resistance to a capacitor, and we will use a switch here which will reset the voltage across capacitor whenever we want to do it. So let's see what will happen at peak. Suppose the peak is attained at some first peak is attained at some time t naught. Then after t naught, Vin may be Vn is greater than V peak, and the value of V out will be equal to V peak. So after that peak is attained, V out will be V out will be greater than V in, which will make the diode forward reverse bias. And when the diode is reverse bias, then we want the capacitor to retain its charge, and we will not we will not close the switch. Uh, uh, we will make it open for all the time whenever V in is less than V peak. But after some time, when V in crosses the value of V peak, then after that diode becomes forward bias. Diode becomes it will become forward bias, and in this case we will close the switch, and after closing the switch V out will become 0, and then again some peak is obtained, and after that peak is obtained, then V out becomes equal to V peak, and it will retain its value equal to V peak until the V in crosses V peak again. So this process will go on, and we will observe a graph as shown in the figure. That is all about operational amplifier and its 3 applications that we covered. Thank you so much.